Good morning, everyone. It's my privilege and pleasure to be here and to be invited by David and the organising committee to give your keynote speech this morning. I'm assured that it passed a stringent PWI quality assurance check, which I didn't feel a thing. So I hope it ticks the right boxes. So where to start? I'm scratching my head a bit with this one. I've always really enjoyed presenting kind of deep technical information through these sort of presentations, but this has got to be something more strategic in my view. So I thought I'd start with some simple facts in my world about the amount of investment we are making in the UK in research and development and innovation in this control period. So £550 million, by my simple mathematics, is a conservative estimate for the investment in R&D and intelligent infrastructure in CP6 that Network Rail and RSSB and other research and development supply chain partners are going to spend. A huge opportunity. All of us in this room have an enormous part to play in getting the best for our £550 million, the best bang for every pound. There's also £820 million being spent across Europe as part of Horizon 2020 research and development. And Network Rail and other UK institutions and railway managers are playing a massive part in shaping how that investment is directed so that it starts to solve some of our UK industry-wide challenges. So nearly £1.4 billion at least on research, development, innovation in the next 4 years alone. So I think our job from here today is to start to work out how we get the best from that £1.4 billion. You're going to hear through the day lots and lots of good ideas from a range of presenters covering the full asset life cycle of the permanent way asset. I'd like us all to take away the nuggets from those presentations and use it to inspire us in our future projects, programmes, collaborations across the industry so that we spend this £1.4 billion to our best advantage as UK PLC. Now, a common theme from today you'll hear is that the innovation, the research and development is closely aligned to a business objective, so not just a technology objective. These aren't just pet projects. These are very carefully targeted developments across the industry. So in terms of a bit of context, here are Network Rail CP6 targets. So in the world of P-Way, we need to deliver improvements across safety for our passengers and for our workforce, and you'll hear later from Nick Millington about the really exciting stuff that is going to go on in the workforce safety task force within Network Rail and how that links very closely to our developments and our requirements for technology in the business. We know that our reliability of the asset and the reliability of the timetable is under very close scrutiny, has been for some time to come, some time. We need to continue working on this challenge. It's not easy, and I've got a slide later that illustrates the scale of the challenge we face here, but we have to deliver this so that our customers retain their confidence in the railway as a mode of travel. And as Stephen explained, it's really important for our future sustainability, the carbon challenge, the climate change challenge for the UK. So we have a key role to play in making sure that people choose rail as a mode of travel. And of course, across Network Rail, we're always looking for efficiency, and I see that as a major challenge. In CP5, our unit rates for track engineering and track renewals increased way beyond anyone's imagination, to be honest. We've got to try and reverse that trend. We've got to get better at managing the value in every renewal and maintenance intervention we make to the railway. Then we've got our people. So we've got a key role to play in making sure that within Network Rail we have as diverse a culture as possible, because that way we'll get creative thinking, new ideas, and really start to make the most of our opportunity for innovation across the business. And then we've talked about environmental impacts, so reducing carbon emissions, but also making sure that we meet the weather resilience and climate change challenge for our asset. For me, we also need to have, for every single bit of innovation and research development, a clear line of sight to our business risks. So this chart, we have in Network Rail a series of bow ties which visualise our risks across our asset base. We also have an enterprise level risk which looks at the risks in our standards and competency framework to make sure that we are improving those all the time. The output from that analysis feeds technology roadmaps, and this is where I think as a business we have more to do to provide you with the information you need to target your efforts and our bigger challenges. So in my view, we should define the future requirements in terms of capability of the P-Way, or in my world, track and S&C, but we're not technology experts, so I need your help to define the technology we need to develop to produce that additional capability over a long period of time. And ultimately that will inform our challenge statements which feed into the funding that we apply for and that you will help us with in terms of the supply chain for delivering our technology roadmap requirements to improve the way we manage risk in future. And a bit more context. As a UK railway system, our safety record is unparalleled. So our history of accidents with passenger fatalities, you're all well aware that the last incident was 2007. So we've got sustained this impressive performance, and this is what the travelling public now expect. So that one of our challenges is maintain this level of railway safety. At the same time as meeting this performance challenge. So the top left graph shows our performance in CP5, the red line shows our PPM performance. On the right of that chart shows the franchise targets for CP6, the top blue line, and there's our recovery trajectory. As Network Rail, that is what we need to try and deliver. But that's a big gap to close. So what are the innovation challenges as I see them? Well, the first one is this place, the valley of death for innovation. It's that point in time where we are trying to translate publicly funded research development into privately invested commercial solutions for our industry. I know we can do better as Network Rail to help you close that gap. One of the ways I'd like to make sure we do that is for every R&D project that my team runs and supports, there's a clear route or regional sponsor for that development. We've started it with intelligent infrastructure and with our CP6 R&D programs, but we can definitely get better at it. There are good examples of how that gap has been closed, and you'll hear about those later today. Looking at things a slightly different way through the lens of Dilbert, we need to stop smothering the good ideas, the innovation. I don't want my team to be seen as blockers to your good ideas. I promise you that we won't be in future. I'm open to all good ideas. Please challenge us. Please challenge the standards framework. Please challenge our accepted traditional practice. I was talking last night to Carl Gareth about best practice across Europe, because one of my objectives in the next 12 months is to do a much more rigorous piece of benchmarking across our key inspection and maintenance procedures to see what we can learn from other railways. I feel like we might have missed an opportunity to date. Challenge 2, don't forget the people. They make it happen. For a lot of our guys, some of the change that we're proposing, intelligent infrastructure, for example, can be quite a frightening thought, that we're replacing inspections out on track with lots of data, lots of desktop-based analysis. Some of our section managers aren't too keen on the thought of moving away from their section manager inspections and relying more on data collected via automated means. So we've got to take them on this journey with us. We need to be open and transparent with them. We have to engage the unions so that we have their support in this longer-term change we need to make to the industry. We need to be aware of the new skills, competencies that our ladies and gents are going to need to develop. Their jobs will change in some cases. We're moving from sort of Mark 1 eyeball type inspections to using drones or analysing remote monitoring data, analysing more train-borne data. That could be quite a big change to a lot of working practices. And then we need to move people away from the hazard as far as possible. And again, Nick's going to cover that later, but I'm fully behind that initiative. And that will demand a new set of requirements for the technology we need in the world of PUA and track and S&C. And we need to hurry up specifying those requirements so that you can respond to them and we can collaboratively deliver that objective. Challenge 3 for me is turning data into information, then knowledge, then wisdom. We're swamped with data. In fact, that's what I have been working on in the world of track and S&C as their initial focus, is making sure we can align that data. Because without the ability to overlay our track geometry with our rail ultrasonics, with our GPR, with our hot weather stressing records, for example, how do we build that intelligence into where to focus our resources, where the risks are starting to emerge, and start to apply a more sort of rapier-like targeting of our efforts and our resources at risk, rather than having to apply a more blanket approach to the way we manage the asset. We definitely need more automation and more train-borne inspection. If we're going to move people away from the hazards of working on the live railway, then what sensor technology do we need to be able to monitor our asset so that we are understanding the level of risk and able to prioritise our response to that risk? It's part of our European research. Talking to Phil Winship last night, we're starting to specify what we need for S&C in terms of monitoring stress, deflection, voiding, impact loading. Why don't we get to a position where for every S&C we install, it's plug-and-play instrumentation, so we can start to monitor crossing performance or switchblade wear. You'll hear later about BIM. Brilliant presentation from Tom on BIM. As Network Rail, we're kind of, I think, in the early stages of understanding what this means for us. I'd like one version of the truth of our entire asset register and our one asset, excuse me, one single map of our asset. We're working hard on this, but we've transitioning from Jogis to a system called INAM has highlighted where we've still got a lot of work to do to align all of our assets onto the same map. But we'll get there. But what does BIM and digital twin mean for us? I've heard different definitions. Certainly we're working on digital twin as more of an aid to training, inspection, understanding the level of intervention required on the asset. So there's quite an exciting future there for me. But again, let's define the requirements so that as an industry, we can target our efforts in the right way. Challenge 4 for me, climate change. We're all very familiar with it. Lots of problems with flooding in the news recently. We'll get to summer and the hot weather will be an issue. More OLE, does that mean we have to be concerned about more storms, more disruption because we've built OLE? Discuss, really. But definitely something that is on my radar and making sure that as part of Network Rail, I align my thinking with our overall policy on climate change, and we work together inside Network Rail to understand how we're going to respond in a coordinated way. Challenge 5, I've put up. This is a draft of the CP7 track asset policy I'm proposing for the regions. It's really here as a reminder to me that devolution is one of our challenges, and I hope it's a massive opportunity for us. We'll have 5 regions, each with a new team of permanent way engineers. For me, that's a great opportunity to make sure that as what will become the technical authority in Network Rail, we align our strategic thinking with their route strategic requirements. So what does each section of route need to deliver for the UK PLC in future? In terms of economic growth, support for local infrastructure. But also, those teams will have a lot of expertise, and I'd expect them to support all of us in this room in driving forward some of the innovation, to get us over that valley of death by testing, by trialling, and by developing the solutions to the point where we can then share the best practice nationally. So I've come on to a few ideas now that I think are, I love these ideas. I think they're brilliant ideas for the way people are tackling our current challenges and innovating. First one, a vehicle-related challenge, and you'll hear a fantastic presentation from Giles later about sort of the future of rolling stock. But I guess a lot of you will have heard of the ActiWheel steering bogie. Brilliant innovation that will reduce track damage, but also opens up lots of other avenues for the way we design the infrastructure and design rolling stock. So these independently powered and therefore steered wheel sets reduce the weight of the bogie by around about 2 tonnes, offer the future option of more space in the rolling stock above the bogie, so potentially double-decker trains. Certainly offer the ability to look at S&C design again. If you can steer a train to change direction, then we could rip up the rulebook on S&C and look at our P-way design again from a whole new light. Obviously, very cutting edge, a long way to go, but really exciting idea. In terms of weather resilience, Network Rail is building a drainage test facility, and the reason I include this is I'm really encouraged that we're starting to put some serious horsepower behind drainage. So we're building this at one of our test tracks, and it'll give us a facility to train our teams on drainage inspection, maintenance, renewal in sort of real scenarios. The test track itself has got some drainage issues, so this is helping solve some of the challenges there as well, or we can test new products, new technology in light of those challenges. And it'll give us a better understanding of how we develop and manage our drainage systems. We're also using it to build in, if you like, the Internet of Things version of drainage sensing technology. So we've got level sensors, we've got soil moisture content, we've got sensors on the rail itself to highlight when there's a flooding risk emerging. So the graph, the sensors down the right show the 3 different types of sensor, and the graphs show an example of the data from those sensors. But these are now providing real-time alerts to the engineers on our IDC about flooding at certain points on the test track. But I'm just really encouraged that we're starting to put more and more emphasis on drainage. Another aspect I'm really encouraged by is the work that's continuing in the world of embankment monitoring and earthworks management. Clearly in the headlines again over recent months because of all the rainfall and the various land slips. We're using track quality data, and we've developed some new metrics to take existing track quality data from our measurement trains and understand the degree of vertical and lateral movement every 10 yards on our embankments. We've tested this over 1,700 embankments up to now, and we're rolling it out on LTN1 at Liverpool Street to do some more validation and assess the numbers of false positives, false negatives, and useful data that is generated by this approach. But certainly encouraging signs so far. We're also testing a system that is actually well developed in other earthworks engineering projects, such as dams, where we're installing sensors that measure the resistivity of our embankments. So we put a network of sensors in. It gives us in effect a three-dimensional plot of moisture content, but also embankment movement. And we're testing this at 2 sites in Wessex. High-risk sites, again, the idea being that we get an early warning of any problems in the embankment. By monitoring the moisture content, we can look for longer-term signs of problems in the embankment, and allowing us to target our precious CapEx at the right locations. You'll have already heard of something called the decision support tool Network Rail is building. This, in essence, is an example of where I think we're targeting our efforts at those people who are making the safety-critical decisions day in, day out, and intervening on the railway to carry out safety-critical work every day. So we're collecting our data together. We're starting to build a kind of holistic picture of the asset condition and the rates of change, and that's key for me. I want us to move to a position where we can monitor rates of change to allow us to know when we need to intervene. So an example here, this is a track geometry plot. The team have worked very hard to develop some clever mathematics to allow us to overlay and align every single trace from our track recording vehicles so that we can get more confidence in those rates of change. The work continues to refine and improve that degree with which we can overlay the different traces. But we've got initial versions of this rolled out to our delivery units, and track maintenance engineers are starting to use this technology in anger to help them with their maintenance planning. A further example, cyclic top prediction tool. So the graph in the middle of this chart shows every single reading from our cyclic top algorithm along a stretch of track. And what we're starting to be able to do is predict the rates of change of those cycles along a length of track by wavelength. We can see where we have amplitudes which are just below our intervention limit. So we move away from a position where an engineer is suddenly surprised that they've got the highest criticality cyclic top defect, because we can see more detail. And the algorithms will improve to automate the analysis and processing so our engineers get the information they need to make a decision quickly rather than having to plough through gigabytes of data. But it's really an example of just the direction we're taking with our existing asset data and improving its applicability to maintenance inspection. Another fantastic example, I think, of some innovation that is targeted at the teams that really need it, and they are helping scope and the requirements for this tool, is a visualisation tool that allows us to design our ESR and TSRs safely and effectively. So this is the Omnicom Balfour BT video imaging from front of vehicle. And the software tool allows you to place within the software all your boards according to the requirements of your ESR and TSR design. It will highlight conflicts. So if the warning marker is being placed too close to the start of the speed restriction, it flags up these conflicts and suggests to the user how to rectify them. So before we've got anywhere near the track. But the really important bit, I think, is once all this work has been done inside the tool, then the software will generate a plan for the ESR, TSR, including images of the sites where each of these marker boards and equipment needs to be placed. So it reduces the scope for error once the teams go out on site to place the equipment. So it's right first time application of the speed restriction equipment. It's got huge interest across Network Rail. In the world of rail management, there's been a massive amount of innovation. And You'll hear about the Felix switch profile measuring system later from Phil Winship in the middle of that slide. That's another great example of where the collaboration between our supply chain and our maintenance colleagues is going to deliver something that will revolutionise the way we look at our switch derailment hazard risk. I think we're going to learn an awful lot from the new data we collect, moving away from that, that manual inspection where we rely on a very thin feeler gauge to work out whether the wheel-rail contact is safe or unsafe at every high-risk switch, to something that is a lot more objective and also allows us to generate those rates of change, degradation rate data as well. I'll also mention induction welding as a project which is perhaps slightly more complicated in terms of getting it through that valley of death process. So we've got a lot of suppliers involved. We've got challenges around IPR. So it's an illustration of some of the considerations we need to make at the start of some of these projects. But we're working towards a prototype, and I think it will be at Rail Live in June, to demonstrate how induction welding is applied to 756 rail. And then just to wrap up, some more examples. I'm a bit of a materials geek, so I've got a couple of materials-based examples here. I'm sure you've all heard about some of the composite materials we've applied in track to replace timber in our P-way. Newark Flat Crossing being the best example, which Phil Winship and others have presented on in the past, installed last year as a replacement for the timber lattice at on the East Coast Main Line. But we're now at a stage where we have pretty much signed contracts for composite replacements for all of our long timber materials. So from this month, Routes and Regions will be able to purchase an extruded or pultruded fibre reinforced composite material that we can use to renew all of our long bridge beams. Removes a lot of the failure modes based in terms of timber degradation, rot, and will give us a more sustainable asset on some of our higher risk locations in future. We're also very close to closing the deal in terms of plastic sleepers. So in the next excuse me, 2 months, we'll be in a position to start to phase out the use of creosote treated softwood timber sleepers. Now the driver there is legislative, so we will be banned from using creosote in our industry at some point in the future, so we had to act sooner rather than later. And it also benefits our workforce in terms of removing a health and safety hazard during the handling of creosote-treated sleepers. And coming soon is a composite bearer for S&C with a modular option. So that's also in the pipeline for innovation later this year. So another example of a successful collaboration between our supply chain, our routes, and members of the engineering community to develop a solution for some long-term challenges. We're doing a lot of work on cast crossings. So in my world, every cracked crossing causes headlines because it more often than not generates some significant delays for our passengers. We've worked extensively with the supply chain over the last 18 months, 2 years, to improve our specification for cast manganese crossings. And from next month, we'll be introducing new designs which will improve the resilience of those assets. But we're looking at some really good research here, really exciting research into what other options are there for materials. We'd like to develop a composite crossing that's got different properties as you go from the running surface through to the foot, because they have different duty requirements, different loading conditions. So some of our European research is targeted at looking at, for example, 3D printing of crossings and other components. I think that would be amazing if we've got a situation where in future we need to replace a crossing. All we need to do is set off a bit of software to start manufacturing in a sort of 3D printing environment, rather than having a 6 to 9 month lead time from our supply chain for a cast manganese version. So, again, a long way off, but really exciting stuff in my view. And then a project that illustrates our sort of move towards what can we automate, what can we make more consistent through the use of sort of computer-controlled process. And this is looking at ways to repair rail defects. So this bit of kit will attach to the track, will locate and mill a rail defect from the surface of the rail, and then we'll put a weld repair back in situ, again computer controlled, and finish the top of the profile grind the top of the weld to leave us with a very high quality weld repair. And this is something we're pursuing through not only our European R&D, but also there are Amy and Rebel have versions of this kind of technology, which they're looking to target at S&C. So we're starting to work with those two organisations to see how we can bring all this together so we have one strategy for automated weld repair of all rail faults. So to finish, I've taken you through my views on some of our challenges in terms of business drivers, economic drivers for innovation. I've taken you through some of what I think the challenges are in delivering that innovation, and I've given you a selection of some of the ideas I think are starting to kind of solve some of those issues. But we've got this massive opportunity, so let's make the most of it. And I reiterate, please challenge my team, please challenge me. I don't want us to stand still. We need to, yes, target our efforts at the places where we need them most, but let's be really progressive about this, and I'm very much supportive of any challenge that we think will improve our future ability to manage our asset. So thank you very much. Enjoy the rest of the day. It will be a fantastic day. I know it will, having seen the presentations, and I'll hopefully speak to some of you later in the day. Thank you.